All right, continue on. Exponent rule 3. Whenever a base is raised to another power, write the base once, and we're going to multiply the exponents. This is also known as the power to power rule. Okay, you may see some people call it that. Okay, let's do some examples with this. We have y to the second power, so it already has an exponent, but then this 5 comes along and it's going to raise that entire thing to another exponent. So notice we have a power to power. Okay, so we have one base raised to 2 exponents. What's the rule say? Write the base and multiply. So it's going to be 2 times 5. It's going to be y to the 10th. Is going to be my answer. So again, if I have n raised to the 7th and in turn is raised to the 4th, my rule says to write the base, multiply the exponents. 7 times 4, that's going to be n to the 28th power. That's an 8. Okay, now this works also whenever you have more than one base, or if you have a fraction or quotient. Let me tell you what I'm talking about. So we have 4 times a to the 3rd, all raised to the 2nd. So if you notice inside this entire group, the parentheses, all of this is being raised to the 2nd power. So what I like to do is I like to separate my bases. I have a base of 4, so I'm going to give it its own set of parentheses, and I have a base of a, but that's already raised to the 3rd power. So if you notice I took this big parentheses right here, it's being multiplied. Remember, all these problems, we've got multiplication going on here. And I wrote it right here, just kind of give each of these their own room. And now I'm going to give them this bonus exponent. Sometimes I call this a bonus exponent. So each one of these will get an exponent of 2. That one and this one. Okay? Well, if you notice this a to the 3rd to the 2nd just looks like this problem right here. Well, what did we do when we have a power to power? Well, we multiply the exponents. So the base of a is going to be 3 times 2, which is going to be 6, a to the 6th. Okay, well, what's 4 to the 2nd power? Well, that's elementary. 4 times 4 is going to be 16. So my answer is 16a to the 6th. So again, don't let that, let me give you another one. Don't let that intimidate you when you see a problem like this. This is being multiplied, right? No, that's not a subtraction, that's a negative. So I'll give negative 2 base its own parentheses. I'll give x to the 3rd, this guy right here, its own parentheses. X to the 3rd. And what's the bonus exponent? Each one will get this extra bonus exponent out here. And all we're doing is using this rule right here. So negative 2 times negative 2 is positive 4 times another negative 2 is negative 8. Use your calculator if you need to. Put this in parentheses. Anytime you have a negative base and you're using your calculator, put it in parentheses. And over here we have a power to power, and our rule says that we'll write the base, multiply the exponents. 3 times 3 is 9, and we have our final answer. Okay? Even if you have a fraction, such as this, x over y 3rd raised to the 2nd power. Now what's the exponent on the x right here? I don't see it. What is it? It's right. It's a 1. Okay? So what I'm going to do is I'm going to break the fraction up. Watch how I break the fraction up. I'm going to give the numerator its own little parentheses room, and I'm going to give the denominator its own little parentheses room. And each one of them, each part of the fraction is going to get that extra bonus exponent. And if you notice, I've just created problems that look just like the first one I did. And we're going to use the same rule. So we'll write the base of x, multiply the exponents. 1 times 2 is 2 in my numerator. And over here, I'll do the same thing. I'll write my base, do the exponents, multiply them, and I get y to the 6th. And that's it. So a couple of more rules, and then I'm going to give you something that hopefully will help you remember all this stuff. We're going to do lots of practice, so don't panic. If you're panicking right now, take a deep breath. Everything's going to be just fine, okay? But you got to commit this stuff to memory. I'm sorry. Rule number 4. any non-zero base raised to the 0 power is 1. All right, so if you want to take a calculator and test these out, if I have 4 to the 0 power, it's 1. If I have negative 3 to the 0 power, it's 1. If I have 5,287 to the 0 power, it's 1. If I have 1/2 to the 0 power, it's 1. Negative 4/9 to the 0 power is 1. A to the 0 power, as long as A is not equal to 0, is going to be equal to 1. Test it out. Okay, this rule is actually based on rule number 2. And it's on my poster, or I'll be happy to explain it in class. I just don't want to take up video time why this has happened. So trust your calculator, trust me, and that'll always work. Rule number 4. Okay, now let me see. Oh, back to this real fast. Sometimes they want to get real complicated. Let me show you this problem. They usually like to try to trick students, so since I'm on your side, I'm going to show you an example where students just take a look at this and they go, oh my goodness, what's going on here? And so this is a pretty daunting looking fraction right here. It's alphabet soup on steroids here, everything. But look, this whole base right here, okay? We're going to remember, we assume that our variables are not equal to 0. So all of this is irrelevant. What does this do? What's it equal to? That's right, it's equal to 1. I don't care what all this stuff is. That exponent of 0 right here guarantees that that's going to be equal to 1, and that's the cool thing. All right, finally, we've got to get our decoder rings on here. Super top secret decoder. All right, so negative exponents, we need to decode them. And it's really 2 steps. We're going to take the reciprocal of the base, and we're going to make the exponent positive. Okay, let me show you what I'm talking about here. And I want you to verify with your calculator if you can. All right, so as I take a look at this, I'm going to take the reciprocal. That means I'm going to flip this fraction over. So this is going to become 1/2 becomes 2 over 1. And we know that that's really just 2, right? Okay, when I take the reciprocal, the exponent becomes positive. Now, take a look at that. Do you know how to do that? Of course you do. The answer is 8. Okay, but again, go ahead and plug this in your calculator and see if you don't get 8 on that. I bet you do, but this is how you do it. Okay, you take the reciprocal of the base, so the numerator and the denominator exchange. If you exchange the numerator and the denominator, the negative exponent goes away. Another example. Hope you're getting some of these down in your notes, because I'm about down to 2 minutes here. Here we go. I can't work this problem right. I can't take a 3/5 and negative 2 times. It doesn't make any sense. So I need to decode it. So according to the mathematical rules, we're going to flip this over to make it 5/3. You notice we didn't change. This fraction is positive, and it still is positive. We just took the reciprocal. We flipped these 2 guys right here, and now we have this. And now we're going to use our exponent rule. Remember what it is? We give each base its own exponent, so we're going to give the 5 an exponent of 2, and then we're going to give 3 the exponent of 2, and we'll get an answer of 25 over 9. Again, check me on your calculator if you don't mind here. All right, we have this. Well, what's the reciprocal of m? It's 1 over m. And when we do that, our exponent becomes positive. And we're going to do the same thing as we did in the previous problem. The numerator gets the exponent of 4, and the denominator gets the exponent of 4. 1 times 1 times 1 times 1 is 1. And we'll write that over m to the 4th power, and we're good. Now sometimes you may be given something that looks really difficult. All right? And if that's the case, remember, when you flip positions in the fraction, your exponent becomes positive. So if a is in the top with a negative exponent, flip it to the bottom and the exponent will become positive. If b is in the bottom with a negative exponent, flip it to the top and give it a positive exponent, and there's your answer right there. So I'll give you one more numerical example here to show you that it does work. All right, and you can check me in your calculator. All right, so both of these have negative exponents. So I'm going to switch positions in the fraction. So 2 with a negative exponent on top will become 2 with a positive exponent on the bottom. Notice the base sign is not changing. The base is 2 here, the base is 2 here. It's the sign of the exponent that's changing. And we'll do this right here. Switch it position in the fraction, and we get 81 over 8. So again, just to throw you one more problem here, how would you do this? Well, there's actually several ways you can do this. You can use the rule for dividing. Remember, when you divide like bases, you write the base 1 and you subtract the exponents from top to bottom. Now you got to remember, you're subtracting a negative 2. Well, what is 4 minus a negative 2? It's a positive 6. Or you could do it this way. You can say this negative 2 in the denominator is going to pop up to the numerator and become positive. Remember, if we switch positions, the exponent becomes positive. So this x to the 4th is staying put. He's already got a positive exponent. But this guy on the bottom with a negative exponent is going to pop up to the top, and his exponent is going to become positive. And we have this. So my time is about up. So now I'm going to explain PEMDAS MAS. And I'm going to do that live. Okay?